So I presented on how we can use twin disc to evaluate different third body materials. What I did show was just looking at different top of rail products, but what is in our paper is also gauge face greases, and also some different environmental contaminants that you may find in the wheel rail environment, and how the hardness of those materials can relate to how much the friction is going to drop under moisture. What I did show was a very small percentage of what could potentially be in the third body. So in future, we plan to kind of look at other, if you look at the bathtub model, some other taps and drains that we may look at that we can study by twin disc to really understand how the third body affects the friction between the wheel and rail.
Thank you.
Thank you.
The next, please.
Okay, to estimate the wheel wear rate, we developed the improved wear map, improved the T gamma wear map. So in the future, so we want to apply the input wear map to estimate the actual wheel and vehicles. Thank you very much.
Thank you. Please.
My statement is how the wheels have better resistance to both wire and hard seating in high-speed railway. And in high-speed railway, the wheel material is more sensitive to the hollow wire or polygonization. Besides, we found that the rail material is wearing quite small in high-speed railway because the axle load is small and the line is more tangent or large radius curve. Without sharp curves, the rail tends to wear lies. So I think in high-speed railway, the wheels tend to be harder. Yes, that's my opinion.
Thank you.
Yeah.
Please.
Okay. And the rate premium is the better with the condition within this test. And it's important because as do the twin disc test because the fault in the rail system, you know the rate range or what happened with this pair. And rate premium is good with combination. The standard with the other reports is same. I don't know.
Okay, thank you. Thank you very much. Are there any questions or comments from please?
This is for Louisa. Mm-hmm. You presented retentivity results, and you had your oil-based product last a long time. Mm-hmm. I was very surprised that the hybrid disappeared so quickly. Surely that has oil in.
It does, but there's many different types of oils, and not all oils are as good at retentivity. So that particular oil used in there might be a lower quality oil that would oxidize quite a bit quicker under the wheel rail.
But quicker than water?
Quicker than, well, I think it's how the overall formulation is put together and how the rheology of those materials are also quite different. And so how that all works in the third body is not really dependent on just water evaporation. So it's really how the whole material as a whole reacts under the third body. And yeah, it doesn't work as well as some of the products. But part of that retentivity is the oil is not as good quality as the oil shown that was completely oil-based product.
Thank you.
Yeah. Oh, no.
For Louisa.
Yes, Don.
So you compared twin disc machines with your field testing of lateral forces, but I suspect your lab data is longitudinal creepage, not lateral creepage.
That's right.
What do you think might be the effect if you evaluated the lab results under lateral creepage conditions?
And that is in the future plan. So our twin disc is capable of doing lateral creep. We just have not done that yet. And you're right. All the testing I did show was under longitudinal creep. And we will be looking into that. And I'll let you know.
Okay, thank you. Please.
Another question. Yes. Another question for you, Lisa. What are we referring to as friction modifier? Are we referring to the high positive friction, because in the railway system we have really great problems with the thread lubrication system, flange lubrication system, and I think that it's important to have this idea
Have
clear.
the positive friction, is that what you're? So we classify it as, and this is sort of a paper done by Richard Stock and Ware, that if it has oil in it, it's not, we don't refer to it as a friction modifier. But as you saw here, that the hybrid did have some positive friction characteristics. So it's not to say that it won't have that, but it's just more based on how this oil and the rheology of the material is going to be completely different and how it's going to perform. So that's the sort of classification we use, is that if it's just pure water-based, we call it a friction modifier. If it's water and oil, hybrid, and then oil, we call it a lubricant. That is not used across the industry-wide. That's just, we're following what is written up in that Ware paper.
But are them for using or for the use of the thread friction modifier? Because the first drop of the friction coefficient is, for me, is quite dangerous.
Quite
because
low.
you have
Well,
always
I mean, you got to realize that the friction on the twin disc is not exactly what's going to happen under the real wheel rail. So anytime you have a new product, you want to just test the material on actual track before. But that drop in friction is, yeah, it does show that, but it also shows good retentivity, and so it's what you need to balance in the actual real rail for that.
Thank you.
Yeah.
Thank you.
Sorry.
I have a question for the third speaker, Xiaobo.
Yes.
So, do you have the other mechanical properties of these tested materials? The reason to ask the question is wear and rolling counter fatigue not only depends on the hardness, but also other mechanical properties like ductilities. So therefore, if you have other mechanical properties, I think you might be in a better position to explain your experiment results.
Sorry, can you repeat that?
So have you did the measurement of the mechanical properties of these materials, like yield strength, elongation, and so on?
Yes, okay. Yes, mechanical properties like yield strength and elongation, right? Yes, and the hardness is a very simple index to distinct different materials, but the yield strength, yes, but yield strength is quite related to the hardness, because there is a brief relationship between the hardness of strings. And so we try to clarify the material by a simple index, but for the elongation, I haven't think about the elongation, right? Because the elongation of the material is quite a plastic index, and in fact the plastic deformation is quite relates to this index. Maybe we will think about and research about the other mechanical practice in further research.
Okay,
Yeah.
thank you.
Okay.
Well, please.
Yes, now I have a question for Xiaobo and Paula. Both of you have done the test in the same direction, and I think that with the rail specimen running faster than the wheel specimen. Have you tested or have you thought about doing the test in both directions? Because I mean, the crack propagation, the wear can be different if you are doing the test, like making alternative runnings or something
Yes,
like this.
but the condition or the test where the twin disc is about the similar condition the Metro de Medellin system. Yes, in the wheel sliding on the rail. So the wheel is more fast than the wheel. The difference with this case with the fatigue, rolling contact fatigue, is the wheel, because it's leading is rail on the wheel. No,
Yeah, I mean,
it's
that
rail on the wheel. No,
especially on wheels, if the wheels are running in both directions, so the crack propagation can be, let's say, in both directions.
But
each
in this moment, the
That's
rail
in your
premium
case for the
is the
rail, yeah.
interesting for the study, but it is other study after.
Okay,
Thank you.
Thank you.
Any other question?
Can I ask one question?
Oh,
Thank you.
please.
Yeah, I have one question for Xiaobo. Yeah. And in your conclusion, you said that harder wheel have higher resistance to both wear and rolling contact fatigue. But based on my knowledge, if the material is harder, but the tensile strength is lower, so it means it's easy to failure under tensile strength. So, do you have any comments on this? Thank you.
I'm sorry, you say the metal is harder, which is lower?
Tensile strength.
Strings.
就是拉应力强度。
Okay. Yes. In fact, we thought that when the wheel becomes harder, the surface outside the tensile strength. Yes. Because as it becomes harder, the yield strength and the tensile strength also grows. Yes. It kind of compensate for the, it can resist more higher the force and the, you say the pensive strength, right? 30.
Yeah, maybe we can discuss later. Thank you.
Yes, okay. Yeah.
The next question.
Thank you very much for your presentation. And I have a question for the third speaker, Xiaobo. And so you concluded that harder wheels are better. But how about the cost? In the real world, you need to take into account the cost. So is it expensive, or is it still realistic to introduce a new material?
The cost.
Yes, cost. So yeah, so you concluded that the harder wheels are better.
Yes.
But you need to take into account. You need to consider the cost to introduce that material.
Yeah.
So I just wondered, the cost is relatively cheaper or still the same level of the existing material?
Yeah, this may have some relationship with the production crafts in factory. Yes, and yes, for these 5 kinds of materials, when the hardness grows and we put some chemical to adjust the chemical composition, yes, the cost kind of grow. Yes, it raised, and but we think that the initial cost at the factory is kind of is more proper. Yes, it's because it's the prolong the service life, and the maintenance interval can be prolonged, and the maintenance workload can be relieved. Yes, so we can't to prefer in the initial cost rather than in the after, right? Did I make it clear?
Yeah.
Yes.
Thank you very much.
Hi, just wanted to ask Louisa about how do you add leaves into your twin disc testing machine, and like any difficulties in that, or how you do that?
No, we just add them, in that particular test, we add them dry because we've already added the water application by a syringe pump under a known volume. So in that particular test I showed, we do it dry. Sometimes we'll form pastes beforehand.
So you've got a kind of a whole leaf or piece of a leaf, and you just
Oh, they're dried
dropping it.
leaves, from literally outside our building.
Okay, the time, yeah, thank you. We have to close this session. Let us thank all the speakers again. Thank you very much. Also,